Hey, Nick.
Hey, Tony.
Looks like I missed all the fun.
Yep, just wrapping up. I think this should be the last one I need to give you the amount of soil.
Brought a sample bag. Let's go ahead and put it in there.
Um,
Well, that gives us plenty there for the laboratory.
Perfect. All
I'll
right.
get this off the lab, get the results to you soon.
Thank you, Tony. I appreciate
Sure
it.
Now you're in our soil lab. We've already gotten Nick's sample processed. And what Dale behind me is doing is the soil pH. He's already done the electrical conductivity. What we do is we take 1 part soil, 2 parts water, add that to it, make up a little slurry, allow it to equilibrate. Dale takes the conductivity meter probe, measures the electrical conductivity, measurement of salts. Too much salts become a bad thing for our turf grass managers and landscape managers. Nick might have mentioned that they have some real problems with high pH, particularly in the sand-based fields. Reduces root development and nutrient availability. We also have a problem here in Texas as well as across the country of low pH. How much limestone do we need to add to bring that pH up to the proper level so root development and nutrient availability is at its optimal standpoint? 2 other tests that we run are nitrate nitrogen and the Malic 3. What they do is they extract out the plant nutrients that we're ultimately going to analyze on our ICP OESs. What Sanders has done is he's added the Malic 3 extraction solution, and we shake this for 5 minutes. What this does is it helps speed up the extraction of that phosphorus, potassium, calcium, magnesium, sodium, and sulfur. Gets it into solution. Kind of fun to watch, but here in a couple minutes, he's going to shut the shaker off, and then he's going to take tray by tray, 10 samples at a time, and he's going to pour them into these filter papers that are on top of similar plastic cups. Well, now Sanders has poured up 60 samples. Nick's sample is in there, and he'll wait for these to slowly filter down through. They're filtering fairly fast today, aren't they, Sanders?
Yes, sir.
It's because these are a little sandier soils. The heavy clay soils we have are going to filter much slower. The next step will be after the filtered, he'll remove the filter papers, those are disposed of, and then transfer the samples into the test tubes right here. Once they're transferred into that, we'll be taking Nick's samples and other client samples down to the ICP for analysis. Thank you, Sanders. Well, we're now in our instrument lab, and we've taken Nick's sample. We already got it on the auto sampler. This instrument that's in front of us is an ICP OES. And what that stands for, that acronym, is Inductively Coupled Plasma Optical Emission Spectrophotometer. And what it does is we take the auto sampler, it's pumped up into this peristaltic pump, and ultimately the solution, Nick's sample, is put into the spray chamber through a nebulizer. We make a microfine mist. That mist is then transferred in pure argon into a plasma. A plasma in this case is 10,000 degrees Kelvin. Super hot, so when Nick's sample hits that plasma, the elements that we're interested in fact all elements, but the ones we're really interested in that we're measuring, phosphorus, potassium, calcium, magnesium, sulfur, and sodium. They hit that plasma and their outer electrons get thrown out. Then they continue into the plasma into a cooler part of the plasma, and then they come back in. And when they come back in, they give off photons of light, unique photons of light, that this portion of the instrument, a super sensitive optics bench, analyzes each one of those. Where the computer takes that data and it compares it to the standards, and then it says, we have this concentration of each one of these elements. Once we have that, we couple it with the pH and conductivity information we already have, the nitrate nitrogen we'd already determined. We put that together in a report, and then I get that report to Nick.
All right, welcome back. We are joined by another special guest. Kirsten Burnett is a senior here in the turf grass science program at Texas A&M University. So why don't you tell us a little bit about that? Clearly you know a lot more about that than I do.
Yeah, so I started working on all the athletic fields at A&M about 4 years ago. And so I never felt like I was at work when I went to work, and I felt like that was a pretty good indication that maybe I should get a job there. And so I added a double major in turfgrass science, and now I'm geared up to graduate in May. So
that's excellent. Well, Kirsten's going to show us everything that she's learning in classes and with this excellent hands-on experience in just a little bit. But first, I want to go back to those soil samples that we were just seeing. So we actually have the results here. Can you just talk to us a little bit about the data that you're seeing and what that means for your job?
Yeah, so we sent that soil test, the soil sample over to Tony. He ran it through all their machines and sent the results back. And so what we're looking at, this is pretty typical for what we see with our fields here at Texas A&M being on a sand base. There's some common nutrients that we're usually a little deficient in. So when we look at these results, the first thing that jumps out to our mind is that we're low on nitrate, nitrogen. Very common in the sand because it doesn't hold on to that anion very well, or cation very well. The second one is the potassium. So nitrogen and potassium, it's very common in our sand-based fields that we're low on those nutrients. So that's why we're constantly putting out a very light rate, frequent quantity, like we're frequently going out with very light rates just to slowly spoon feed the plant, just to make sure it's always there and available for the plant. The other thing that I kind of always check on is the sodium levels, just because of our water quality that we have here. Sometimes we're fighting sodium levels that build up in the soil. Not an issue with this soil test, so doesn't concern me here. And then the very last thing that we really focus on with these results is that pH number. There's kind of an ideal range we're looking for. This one came back a little bit high. It's showing a pH of 8.3, so there's some steps that we'll probably take with our fertility plan and what we put out as far as trying to manage our pH and bring that back down a little bit.
Great. And so you and Tony both mentioned that the way that you manage the nutrients is going to be a little bit different on a sandier soil, because a sand-based soil like the one you have here on your turf fields is going to percolate more quickly. Is that correct?
Absolutely correct.
So Kirsten is actually going to show us a demonstration of that, a hands-on activity to show us why that is the case. But she's got some students to help her out. She really doesn't need us. So let's just leave it to the pros. We'll be back in a bit.
awesome. Thank you guys so much for joining me. I definitely could not do this without your help. So if you could just introduce you guys for me.
I'm Miriam from Kingwood.
I'm Greg from Kingwood.
I'm Gerardo from Kingwood.
Awesome. So the first thing that we're going to talk about is the minerals and the different particle sizes. So soil is composed of sand, silt, and clay. And so here to represent our sand, we have cereal, and to represent silt, we have some granola, and then we have oatmeal to represent our clay, which is the smallest particle size. So if y'all can take the cups that are in front of you, and I want you to pour up to the line each of your particles in there, please. And after this, we're going to pour some water in there, and we're going to have a race to see how fast the water moves through each of these different particle sizes. That's awesome. Okay, who do you think's going to win this race?
The tricks.
Me.
You think you're going to win? I love the
Definitely me.
confidence. All right, let's see if you're going to be the winner. So take your water, and on the count of 3, I want you to slowly pour it in. Or go now. He's just so eager.
Oh, I thought.
No, you're good.
I mean, it's not. It doesn't really matter.
So as you can see, it's not going through the oatmeal very fast at all, and it is starting to get through the tricks a little bit faster. And so that's because the sand particles are larger, which means that there's more space in between each individual particle, which means the pore space is bigger. Therefore, the water is going to flow through sand a lot faster than it would silt or clay. And so here on A&M, like Nick was saying, we do have sand-based fields. So we need to keep that in mind when we're applying fertilizer, because we don't want the nutrients to go through with our water. So we apply at a lower, more frequent rate so that our plants can take that nutrients up. And another thing to keep in mind for nutrients is the charge that our soil has. And so we're going to do another experiment to show that. We're going to show that soil acts like a filter. So if I can get you, Marion, to please pour this dirty water, and we're going to see how soil acts as a filter. Now, do you think it's going to come out dirty like that, or do you think we're going to have clear water?
Clear.
Clear? Okay. Let's see if you're right. So it might take a couple minutes for it to drain properly, so we set some stuff up earlier. So this is it after it had drained for a few minutes, and as you can see, that water is clear, and that's just because our soil acts like a filter, and it's going to filter all of that out, and we're just going to have clear water. And so another thing that soil does, it is charged. So To show that, we are going to take this purple drink powder, and if you can just mix up some water in there, you don't have to pour the whole thing in there, but just swirl it around for me, and we're gonna pour it in here as well. And we wanna see what is gonna come out, if we're gonna have clear water, if we're gonna have purple water, if we're gonna have something else. So what do you guys think that we're gonna have?
You have clear water.
Clear water, you think again?
Clear water.
Okay, let's see if we got clear
this
water.
one?
Yes, pour it in there. Awesome. So again, it might take a few minutes, so we sped up the process. And it actually came out to this pinkish color. That's because your soil is charged, and so like charges will attract and opposite charges will repel. And so in our soil, it attracted the blue dye, and so the blue stayed while the red dye went through. And so that's important for our nutrients, that we want to understand our soil so that we can know what nutrients to have in it. And so I know that y'all had prepared a few questions, so if Nick and Terry can come join us real quick, we'll get to those. All right, Miriam.
All right, so Abby Mann from Serrano Elementary, California wants to know what kind of degree should I think about getting if I want to be a turf manager?
Okay, so it really depends on what school that you're going to, because every school has a different major or department that you can go into. For instance, here at Texas A&M, I am a soil crop science with an emphasis in turf grass science. And so it's gonna be different wherever you go, but you can do anything from agronomy to horticulture to plant science. There's just so many different things that you can do if you wanna go into this industry.
This is from Daryl Thomas of Rockingham Middle School in Madison, North Carolina. Wants to know how have playing fields changed over the years in college?
I'll take that one. Daryl, to answer your question, there's kind of two main things I'd really focus on as far as how fields have changed in the management of over in college. The first one I would say is if you went back and watched a college football game from 15 or 20 years ago, you would probably, and it was a rainy game, you'd probably see them playing in the mud essentially. Back then, you know, college athletic fields, especially football fields, you just built the field on whatever soil was there wherever you wanted to build your field at. So it was whatever native soil was there already. You planted the grass, put the grass down, and then you played ball. The change we've seen is like what we do here at Texas A&M now, where we do a modified soil, or we rip all that natural soil out and we put sand back in to ensure that it'll drain and so that it's not a muddy field when we're playing in the game, and creates a better environment for the game to occur, so there's less chance of affecting that with the field. The second thing I'll say that we've really seen over the last probably 10 to 15 years is that we've incorporated a lot more science into how we manage the fields. Back in the day, athletic field management used to be considered more of an art than a science, where it was just kind of a touch and feel and you learned it as you went. Well, now we have a lot more analytical tools that we can put to use. For example, I talked about the soil laboratory earlier and how we can analyze what nutrients are in our soil and use that to make management decisions. So we've got tools like that and other instruments that we can use to test how hard a field is and how good the traction is and how much water it's holding. So we're able to put a lot more numbers and use scientific data to really gauge what we're doing on a daily basis and how we manage the fields.
Angelica Fleming from Snelson Golden Middle School in Hinesville, Georgia asks, is there a certain type of species of grass that is best for football fields only?
Great question, Angelica. So I'll answer that one as well. There's not really one specific type that's going to universally work across the board. A lot of it's actually geographically based. So depending on where you live in the country will dictate what grasses are being used and why. So there's two main types of turf grasses, or grasses that exist in the world, and they're called cool season grasses and warm season grasses. And it's all about the climate that they prefer, whether it's cooler temperatures or warmer temperatures in which they grow best in. So if I get up to the north in New York, the California, or Northern California, Iowa, kind of that northern climate, that's where we're going to grow the cool season turf grass species. So most of their football fields or athletic fields are probably going to be on something like a Kentucky bluegrass, a tall fescue, another fescue type species, maybe a ryegrass. That's very common in the north. Now when we come down here into the south, into Texas, Florida, Georgia, Southern California, we use the warm season turf grasses. And probably the most predominant one that gets used on athletic fields is Bermuda grass. Now there's different types, common Bermuda grass, hybrid Bermuda grass, but they're all Bermuda grasses at their base. So those are kind of the common ones.
Well, guys, thank you for sharing those questions with us. And thank you so much for your time, Miriam, Greg, Geraldo. Thank you so much. And we're really, really happy to have you, Kirsten, here helping us. And, you know, I hate to say it, Nick, but I kind of think she might have your job someday.
I think she's gunning for me eventually.
She's on the way. She's on the way. But speaking of your job, I got a chance to sit down with you a little bit more earlier and hear what a turf field manager does all day. And so let's hear what you had to say.